Hello everyone, in this video we will try to solve the following exponential equation. Notice in this equation we only have one term where the variable we're trying to solve for, in this case it's x, it's in the exponent. So hence we have an equation that we call exponential equation. To solve this exponential equation we have to make sure and count how many terms do we have that are actually exponential terms. Notice that we only have one term that is an exponential term. So step number one, our goal in step number one is to isolate exponential term. Okay. To isolate exponential term, we will need to move negative 125 to the other side by adding it. This is what it's going to look like. Base 5 to the power of 9 minus 3x on the left-hand side equals, and now we have 125 on the other side. We have a property that is called same base property. That will allow us to remove the variable we're trying to solve for out of the exponent. As of right now, this exponent, imagine being embedded in this exponential term. We cannot simply drop the 5, because if we drop base 5, we now created a completely different problem where we only have 9 minus 3x. Well, 5 raised to a power is not necessarily will be the same as 9 minus 3x. So we're going to have to find a way to remove this term, the term that has an x, out of the exponent. To do that, we go back to the idea of the same base property. Same base property says something like this. If we have an equation where we have one base with an exponent on one side, one base with an exponent on the other side, the property says if, and this is if and only if our bases are the same. So if this base b and this base b, if bases are the same, so this is if bases are the same, then we can say that the exponents, this m, will equal to this n. Now let's look. On the left-hand side of our problem, we have a base 5. On the other side of our problem, we have a base 125. Remember, right now, our bases are not the same. We want our bases to be the same. So we're going to have to come up with some idea to convert these bases to the same base. Well, think about it very carefully. 5 can be written as 5 times 1. 125, if I prime factorize 125, that would equal to 5 times 5 times another 5. All right? Another way of saying 5 can be written as 5 to the power of 1, and 125 can be written as base 5 to the power 3. Now let's see what we have. We have 5 to the power of 1. That's still going to give me the original 5, but the original base 5 was raised to the power of 9 minus 3x. Now let's see on the other side. 125, we will just simply rewrite it as 5 to the power of 3. Keep in mind, what we did is we simply rewrote the original problem. We didn't change anything. 5 to the power of 1 is still base 5. 5 to the power of 3 is still 125. We simply rewrote the problem. But the reason we did this, now, if we notice, our base 5 and this base 5, exactly the same as the property tells us. Now we can use the property. If bases are the same, and now our bases are the same, that means we can equalize our exponents. If we go back and equalize the exponents, we'll have 1 times 9 minus 3x Remember, when we have one base raised to two exponents, we multiply the exponents, equals to the power of 3. Remember our goal? Our goal was to remove the power, 9 minus 3x, so it is no longer a power. Notice what we did. Now, 9 minus 3x is not a power any longer. When we distribute a 1, we'll have 9 minus 3x equals 3, and this becomes our linear equation. Okay, all right. Now, before we go on and solve further, let's quickly review. Step number 1 is to isolate exponential term. This is where we isolated the exponential term. Now, step number 2, this is where we try to see if we can use the same base property, and we've done that. And now we are on step number 3, where we try to solve an equation. Sometimes you'll have a quadratic equation to solve. Sometimes you have a linear equation. Look at the highest power of x. The highest power of x will tell you your next step. Here, the highest power of x is 1, so we know this is indeed going to be our linear equation. And we will try to solve this linear equation by isolating x. Subtracting 9 from both sides. 9 minus 9 is 0. We have negative 3x equals, combine like terms, we'll get you negative 6. And now when we divide by negative 3 on both sides, we can isolate x. Remember, isolating x means leaving x with a coefficient of 1. If we divide negative 3 by negative 3, that's going to give us a coefficient of 1. Let's see what the x will be. On the left-hand side, we have 1x equals the right-hand side, 2. So it looks like x is 2. It looks like we're done. But we always want to check to make sure that we are indeed done. Let's check our solution. We will check this x equals 2. What does that mean to check? We want to make sure in the original equation, we want to make sure that the left-hand side, whatever it will be, must equal to the right-hand side when this x is tested for x equals 2. Let's try and see. 5 to the power of 9 minus 3x, 9 minus 3, but everywhere you have an x, and we only have it just here, we'll substitute a 2, so times 2, minus 125, and we want to know if it equals to the other side, which is 0. Let's see. 5, remember this is your exponent, to the power of 9 minus 6 minus 125, we want to know if it equals to 0. All right, now let's see. 5 to the power of 9 minus 6 is 3 minus 125. We want to make sure that it equals to 0. If we raise 5 to the power of 3, that will give us 125. And now notice, 125 minus 125, it's indeed a 0. So this solution, x equals 2, checks both sides of the equation. Equation is balanced when x equals 2. That means we can finally write that the solution to this problem is 2. And we write it in a solution set. And we're done.